How do you see the earth science community right now? Do you see it as a dynamic community in terms?
No, not right now. No. Right now, at least in the United States, it's driven. It's driven by what I call the NSF National Academy Cartel. It's a group of people who decides what needs to be studied. With the data management now, as I see it, is data management is so fossilized or so embryonic, if you wish. It's like an early Ford. So what you need is something which allows people to ask the right questions, trains them to ask the right questions, and stores the information in a form that you can retrieve it. And that you can also retrieve the old song. If the first place I would go to for data management to find out is go to the Vatican.
I think we are losing some excellent geological contribution just because they are not written in English, they are not presented in international convention, and the guy who wrote that contribution is not known around. Depends very much on the frenzy. I'm very pessimistic. You have to conform, absolutely do conform with this international magazine. And this kills the original research.
You definitely, well, I don't know if you can get too quantitative, but you get into this dilemma of knowing more and more about less and less, you know. There is always a danger of getting led into getting so fascinated with getting quantitative data that you forget to ask important questions, or you forget to your research can get driven by what you can do, not by what you should be doing, you know.
So, I mean, yeah, you represent the core of the base of classic geology. And who's following you?
This is a good question. I think we have a gap. And it will take one or two generations to fill the gap. Because most young people don't do field geology simply because their professors don't know to do field geology.
So you mean a gap or a black hole?
A black hole, indeed.
Everybody is supposed to test hypotheses. That's not the way it works today, and that's not the way it ever worked. It's new data and new systems and new information. So the hypothesis is a consequence of the new information, and the information is not a consequence of the hypothesis.
Every new technology drives new questions that can begin to be answered by the new technology, by the technical advances.
And I think that technology is great, but on the other hand, you should have a real good naturalistic historical background. Geology is basically an historical science. It's like to restore it. You know that recently the last dinner of Leonardo was restored completely. That through pure technology, but the paint is made by Leonardo.
How important is the serendipity in research?
Oh, I think it's the most important. When anybody breaks into a new field, it's always due to an accidental discovery that you don't expect. If you're working on things that you sort of know what you're going to get, you make little tiny steps forward. If you're going to something totally unknown, you have the possibility to make a great leap forward or precipitous fall, who knows?
Oh, I think it's always serendipity. I think you typically want to explain data in terms of things you already know. And so you don't go out looking for surprises, you go out looking for confirmation. And then when you don't find it, then you start to think, and you say, maybe these rocks are trying to tell me something. And so that's typically, that's the way it's always worked for me.
You know, you can't work on big ideas all the time. You just don't have big ideas. So I like to go to the field, because when I go to the field, I see all the things I don't understand. And that's so important to remember that.
Well, listen, I'm famous because I sat for several models. I create a model the day after I don't like it anymore. Because if you keep thinking in terms of model, you crystallize and research doesn't go on. So it's a way of thinking, the model. It's not nothing else. And then if you keep thinking, you modify it. If you keep working, you have to modify your model.
And so I'm what you'd call an opportunist. I think I'm pretty good at finding a rose in a field of weeds. But after a while, I like to do something else. But I think a better career is for someone to maybe stick with one thing throughout that. But I get tired of it. And so I like to change over time.
My problem has been I've always been very general, not specializing a great deal.
I was fortunate that every time a new opportunity came along that looked like it was going to be important either to my career or to the country, I was able to make the change and apply my old skills and learn new skills that to that kind of an opportunity.
I think we have still a lot of things to learn from rocks. Lots. If I'm lucky, I think I would say I understand 20% of what I see in the field, if I'm lucky.
The question is, how does a paradigm shift start?
Well, I suppose it's different with every paradigm shift, but it's always driven by the data. You find that you acquire new data and you try to explain it with old ideas. And then you maybe deny the data for a while, and eventually you come to a point where you can't force old ideas to account for new data, especially new types of data. And so then you're forced to say, okay, we need to do something else. So I've been lucky to be associated with several of these paradigm shifts in my career.
The important thing I think about today's world is that no single person has the skills necessary to solve the problems we face, many of the problems we face today. You put together a team with different but overlapping skills and magic happens.
It's great.
And I think the universities are going to have to, are moving in the direction of reflecting that organization.
So we put together a group that was made up of geologists, geophysicists, and geologists that had outcrop experience, and then what others with exploration experience, and we didn't have the paleontologists in the group. We had the use of the paleogeology department, and then we had programmers, and what we'd say, we'd brainstorm. The idea is, if we had all the money we needed, and what would we do? And so this is what we'd work on.
Field geology, believe me, there's no way to teach the way to do field geology. Either you have the talent to do that, or otherwise stay at home. There's no way. There's no way to teach the way to do field geology. There is no, I don't know of any manual, many field courses that can teach you. You move according to your curiosity.
Well, obviously the professionals want to know the big picture questions more, I would say. And with academics, you tend to get the interesting but not necessarily practical details. You know, they're interested in what this little worm is doing and what kind of a structure it might make in the sediment and how you can recognize it.
The map is a representation of the mind of the map maker. So that's what a seismic section is like. It really reflects what's been put in it by the geophysicist, and by cooperating with geologists and understanding what the geologist is talking about, he can change. He can tweak parameters to bring out or to suppress various features.
Well, what I do, I look for an anomaly, one that didn't fit, and then I go and I'd search out some more information.
Stage being the champion of freedom, and everybody involved in the Apollo program felt that it was very, very important for us to succeed in winning the race to the moon. Science came on as a backpack, if you will.
And it's very difficult to know at the end of the day if the final idea is entirely yours, or you thought in the morning, or your idea has been modified in a way or another by discussion. That's a very solid problem. And you will never be able to answer that question. How much is yours, how much comes from the discussion, honest discussion.
But I think to question and challenge those are really the key properties, the key attributes that any good student must have.
So ask yourself about your inner level of passion.
Don't be afraid to follow radical concepts, even if your professors say you're nuts or something like that. Have the courage to follow up your own discoveries.
Take courses that don't make you too specialized.
Be patient, read a lot, do a lot of field work, and have the chance to find a good professor.